I am Vaibhav Srivastav from Vaibhav E-Learning Academy, and today we are going to continue our topic of calculus, and this is our part number 2, that is about limits. In the previous video we have learned about the definition of calculus and the origin of calculus and the controversy between Newton and Leibniz. In today's video we will be continuing the topic and we will be learning about limits. In the previous video, when we spoke about what calculus is, we understood that there were three functions which are required to study the topic of a calculus, and the three functions were limits, derivatives and integrals. These were the three functions which were required, or the main tools which are required to study calculus. In today's video, we will be focusing on the topic of limits, and we will not be going into the extreme depth of limits. We are just going to understand what limit is. We will try to understand it algebraically and we will try to understand it graphically, and then derivatives and integrals will be in depth and a detailed topic. So I hope you will enjoy today's video. Let us start with the topic of limits. So limit is nothing but a mathematical function. It is a mathematical function. Now, before moving on to the actual concept of limits, we have to understand what a function is. Now, I have explained this a lot of time, even in the video of logarithms and even the previous video, that functions are something which are related to a relation. Now, the best example to understand relations and function is, for example, there is a switch over here and there is another switch over here. We have two switches. If we turn on this switch, the fan turns on, and if we turn on this switch, the bulb turns on. Now this is called as mapping in our everyday life language, and this is known as relationship, that the switch is related to the fan, the switch is related to the bulb. Now if there is a certain type of switch which when turned on, turns on both AC and the light or the bulb. Now this is also kind of mapping, but this is a relation. These are also relation, that the switch is in relation with the fan, the switch is in relation with the bulb. Here the switch is in relation with both AC and bulb. Over here, these both are functions, but this is not a function. So we define that function is something which has a unique output for a given input. Now this switch, which is said to be a relation but not a function, it is not a function because it does not have a unique output. It has multiple outputs, that it has an output of both AC and a bulb. So it is not said to be a function. Now we understand what a function is. Now let us talk about limits. Now before again entering the topic of mathematical limits, let us try to understand what limit means in English, general English. If you talk about limits, does it mean something like a boundary? Talking about a limit to something is about a boundary of something. Limits can be associated with something to stop. So that is our limit, and we should stop until we reach that, or we should stop after that. So these are called as limit in our everyday English language. Now how are we able to understand the concept of limit? What actually a limit is? So let me give the definition first, and then we'll be understanding through everyday examples. Talking about the definition of limit, it is nothing but a number or a value which we can reach as close as possible, but never reach it. This is the definition of a limit function, that a limit is nothing but a value which we can reach as close as possible, but we can never reach it. For now, we need to note the definition and we have to move on. To understand this definition, we need to understand some examples about limits. So let us start with the examples of limits. First, we will be noticing some examples of everyday life, and then we will be taking a mathematical example. Talking about the first example, road with a pothole. So this is one very good example and very famous example to understand limits in our everyday life. Now how can we understand that? Let us suppose there is a road over here. This is nothing but a road. And there is a manhole over here. Manhole or a pothole where the sewage works goes. Now we are at point A and we have to reach the point B. Okay. We take steps to reach, right? So our one step covers 1 meter. Hypothetically, one step covers 1 meter. And from the point A, at 3 meters, there is this pothole. Okay. So I will be having a limit here of 3. Now what is the meaning of limit of 3? Now if I take one step, I will reach over here. This will cover 1 meter. Then I take another step from here. I will reach over here, suppose. This will be the second meter. Now if I take the third step, I will be inside the pothole. It will be under the ground. Why? Because at the third meter, we have the pothole. Now when I am standing at the second meter, if I take half step, from the second meter, if I take the half step, then our total distance covered will be 2.5 meters. This value is close to this value. Now from the second step, what if I take 3 by 2 steps instead of 1 by 2? If I take 3 by 2 steps, then I will be at 2.75 meters. Now this 3 by 2 value is definitely smaller than 3 and I am trying to approach the value of 3. I can go to 3 as close as possible. Even if I stand over here at 2.99999 meters, I will not be inside the pothole because the pothole starts from the third meter. So 3 is said to be a limit. Now can we get back to the definition? A limit is a value which we can approach as close as possible, but we can never actually reach that value. So we are trying to approach the value of 3 as close as possible, but we are not actually approaching the 3. And why are we not able to approach the 3? Because that is our limit. If we go to the third value, it might not be good for us. We will be under the water. Now this was the first example. Similarly, there is a second example just as same as the first one. That is a broken bridge example. The second example is of a broken bridge. Broken bridge. It is the same thing. There is a bridge over here, but there is a crack in the bridge over here. This time we are at point A and we have to go from point A to point number B. It's the same thing. The question is, if this is the value, let us say 5 meters. The value of the crack in the bridge is at 5 meters from the ground. So ground in the sense of from the road. So what is the limit over here? In our case, our limit over here is 5. What is 5? 5, the value of 5 meters. 5 meters is our limit. Now, if we walk till here up to 4.9 meters, we are safe. We will not fall under the bridge. Why are we safe? Because the crack starts from the 5th meter. If we go to 4.99 meters, that is just as close to the crack as possible. Then also we are safe. Why? Because the crack hasn't even started yet. Right? So this is how we can understand the concept of limits in layman language or in everyday language. Now let us understand the value or the concept of limits in a mathematical language. Let us see. So now let us understand what limit actually means in terms of mathematical examples. Now here we are going to take one example which is very good and very famous example that if you read a book about calculus or if you read about calculus online anywhere, this example is most frequently seen. So let us see what the example is. Here the example is limit x to 2 for the value x square minus 4 by x minus 2. Now this is a very good question because it can range from as simple as possible and to a good level of understanding. Now there are many complex cases where the powers reach up to 3, up to 4, up to 5, but we are going to learn about the basic concept because you have to understand what a function is. This is actually the function limit is. This is actually an example of a limit function. Now how is this actually read? This is read as limit x to 2 in the value of x square minus 4 by x minus 2. This is how it is read. It is read as limit x to 2 in the value of x square minus 4 by x minus 2. Now from our previous examples and previous understanding, what did we learn about limit? Limit is the value which we can try to achieve but we cannot actually achieve it. It is just like an ideal situation where we can try to achieve it as much as possible but we cannot actually achieve it. So our value of x is 2. Now we already said that we cannot achieve that value for some reason. Now the question is, what is the reason? Why can't we achieve it? One reason is because our interest of study, our area of study is required up to a certain area. So we do not cross that area. Hence we apply a limit over here. But what if there is some other case? Now this example will help us to understand that. Suppose we take the value of x to 2. Forget the numerator. X square minus 4 by, if we take the value of x is equals to 2, then this x value becomes 2 minus 2, which becomes x square minus 4 by 0. And this is nothing but anything divided by 0. And we know that this is not defined. So in the concept of limits, we are going to understand why anything by 0 is not defined. Because we know that if you take a value 1 by 0, this is not said to be 0, this is not said to be 1, this is not said to be infinity. It is said to be not defined. This is the question, why is 1 by 0 not defined? So we can use the concept of limits and the concept of graph to understand why is 1 by 0 not defined. So for now, we will leave this topic for in future. But at the moment, let us focus on this topic. Now, x square minus 4 by 0 is not defined. So now we understand when we limit the value of x, then the equation comes out to be not defined. So now again we get the topic of what a limit is. We are trying to get to that value but we do not actually achieve that value. Here we took an example of what if we actually achieved it. If you achieve the value, the equation becomes not defined. So this is a case where we cannot actually define the equation when we approach the limit. This was an example, a mathematical understanding about what a limit is. Now let us take our questions and our problems one step further. Solution for this problem will be solving this question later on in this video or in this topic of limit. But for now, let us keep this question on hold and we will continue the solution later on. Now let us take an understanding or an example which is algebraic. We are going to take one example to understand the concept of limit again. So we have a question over here where we limit, not even a question, it is just a statement, right? Where we limit x to 2. And this is our equation. Not equation, an expression where we are limiting the value of x to be 2. Now here we have applied a limit of the value x to 2. Let us suppose x cube is equals to y. Our limit is that x should have a limit of 2. From the definition, we can say that the value of x should try to achieve the value of 2, but it should not actually achieve the value of 2. So, let us draw a number line. 0, 1 and 2. This is our point of interest, 2. The question is, how can you achieve 2? You can achieve 2 from two different directions. One from the positive side. I am giving a convention, let us be this point, let it be positive. Why? Because it is coming from positive infinity, 10, 9, 8, 7, 6, 5, 4, 3, 2. Achieving 2 from the positive side. We can also achieve 2 from the negative side. Like coming from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1 and then 2. There are two ways to achieve the value of 2. We can go to the value as 1.9 or 1.99 or something. And from here we can achieve the value as 2.1 or 2.01 or something. So these are the actual values which satisfy the limits. It satisfies that the value of x should tend to 2. Now it doesn't care that x is tending from 2 from the positive direction or the negative direction, but we have a limit applied that x should tend to 2. If the value of x is equals to 2, then the value of y becomes 8. Okay, this is our general equation. If the value of x is 2, our value of y is 8. But for some reason, let us take an hypothetical reason, for some reason the value of y should not achieve 8. So maybe there is a porthole at the 8th meter from the starting point. So I don't have to attain the point of 8 in the y area. Now how are we going to understand this? We are going to substitute the different values of closer values to 2 and we are going to find out what the values of y are. Now for this we have to do some mathematical values, mathematical calculations. Let us suppose the value of x is 1.9. What will be the value of y? The value of y will be 1.9 whole cube, and for this we have already done the calculations. Then the value of y will be nothing but 6.859. We are approaching the value of 2 and our answer y should also approach the value of 8. Let us take one more example. Let us suppose our value of x is 1.99. Now this value of 1.99 is much closer to the value of 2. Then our value y comes out to be 7.88. Let us suppose the value of x is 1.999. I am increasing the value, I am increasing the uncertainty to get the value of 2. The number of significant figures over here has increased. Then the value of y comes out to be 7.98. Now we are actually very close to 8, but this is not exactly 8. Let us suppose the value of x is 1.9999. The value of y comes out to be 7.999 or something. Now here we get the idea of the limit. First we approached it from the negative side. Negative side in the sense from the 0 side. So I call that as negative side for example. So when we are trying to approach the value of 2 from the negative side, then as you are increasing the closeness to the 2, the answer of y is increasing to the closeness of the 8. This defines our definition of limit, that a value which we can get to as close as possible. Our value is over here, that is 8. We are getting to as close as possible, but we are never actually attaining the value of 8. This is a beautiful concept of limit in mathematics. This can be also proved otherwise. How can we prove it otherwise? Let us suppose we are achieving 2 from the positive direction. Let the value of x be 2.1. Then what will be the value of y? If the value of x is 2.1, then the value of y comes out to be 9.261. Interesting, because our x value is about to hit 2 and our y value is also about to hit 8. If the value of x is more uncertain, 2.01, which is almost equal to 2, then the value of y comes out to be 8.120. Now as we reach 2 closer, the value of y reaches to 8 much closer. X is 2.001. We are more closer to 2 right now. The value of y comes out to be 8.01200. It keeps on going. But now if we remove all these terms, this is nothing but 8. Again, if we take one more last value, 2.0001, then the value of y comes out to be 8.001206, and it keeps on going. Another beautiful understanding over here is that as the value of x is approaching 2, we had the limit over here as 2. As we are trying to approach the value of 2, our value of y is approaching the value of 8. This was a mathematical proof of what a limit is, an algebraic proof of what a limit is. Now we discussed about the concept of limits. Limit has a very beautiful application, and one of the applications is to find out how the graph of an equation looks like. So we'll be understanding limits in a graphical term right now. So let us see.